to welcome to this video. We're going to be talking about debugging the kernel today. Um, I think we have some videos in the past of debugging the user application, but somebody had pointed out that they were having problems debugging the actual kernel, and one of those was that they were running into the fact that we actually randomize kernel addresses when you boot it up. So every single time you boot an application, we're actually randomizing a bunch of stuff in memory. And this is a security feature, but it's troublesome if you don't know about it and you're trying to debug something, especially because then you can't see symbols. So like you don't know where something is in a file because you don't know the actual memory address. So we added some support to make this easier for people to do. And so these were the instructions for just debugging like a normal user program, basically where we inject this seg fault. And this works. This is great. But for this video, we're going to be talking about the actual kernel. So the first thing we did was we made this flag, no KASLR. And so if you're going to do this, you need to download Nanos itself, and you have to build it from source. And the reason why is because if you're going to be debugging the kernel, you're probably going to be changing the code at some point, if nothing else, like throwing in a printf type of thing. So it doesn't really make sense for us to distribute this, at least we can't think of a reason why. But yeah, so you download Nanos, and then we're gonna go ahead and build it, right? Now I've already done this for this video, so this is gonna run pretty fast. But we get our build, and then maybe we have a user program, and in this case I'm just gonna do like a hello world of Go, so really basic, right? And what we're going to do is we're going to set the kernel to the version that we just built. So normally when you're doing ops run, this just downloads whatever the latest greatest is, or maybe you do a Nanos version, or maybe you do like a nightly or whatever. But for this, we're going to set it to what we just built. And so this is where for x86 it gets put in here. For ARM, it's going to go to a different location. And so what we can do now is we're going to go ahead and run it, right? This -D basically starts up a GDB remote listener. And so what that does is it boots and then it just pauses and allows you to connect to it. So we do this, right? So now it says, hey, by the way, you can connect. And then let me just show you this real quick. This is also an important part that other people might not know about, is where these addresses are actually loaded at. And so each of these, we have some for each architecture. So RISC-V, ARch, 64, and x86 64. And so we're just going to go ahead and start this GDB. So this is our debugger, right? And then now we can actually do stuff. So what we could do is, we could set a breakpoint for, say the right syscall that is being used. And so, in fact, it's like, yeah, syscall.c. All right. Let me just show you this real quick. So if we go into source, and then we go into, I think it's Unix, and then syscall.c, and then we'll do sys return right. So this is actually our right syscall entry point right here. And so when you do like say printf, for instance, eventually it's going to call this, right? And so it's got your file descriptor, your your string, and then, you know, how long it is. And so what we can do just as a test here is to kind of just break whenever we call this, which is the very first thing that our hello world does, right? So we set it, and as you can see, it's kind of set it fine. And then we can go ahead and continue, just see or continue. And I screwed up. So I used the wrong config. So this debug JSON is actually what we want, right? So let me run this instead. And do we got to see? There we go. So let's try this again. All right. So now we're running. We're gonna set our breakpoint again. We hit set. We hit continue. Okay, now it's working, right? And so you know, we can just do normal GDB related commands. We're actually inside the kernel now. We can see the lines that we're looking at. And as you can see, 250 is like right where we should be, right? We can do body. So obviously this is our string that we're printing, you know, the length, all that good stuff. And we can just debug it as we need to. And so, you know, we don't really expect the average Nanos user to sit here and debug the kernel. You know, that's up to the kernel development team. But what it could do is allow you to start pinpointing where you might be running into an issue if you do run into an issue. And so, you know, that just makes things easier for everybody involved. But this was a quick little intro to debugging Nanos, you know, especially with KASLR turned off. Until next time, bye.